All right, I have a lot of things going on here. If I was taking the derivative, this would be a product rule and a chain rule. Let's rewrite it though so we can see where the composite function in this problem actually is. So based on what you just said to me, what am I going to pick for my u?
Sine, right?
I'm going to pick u equals sine of 3x.
Oh, how'd you know to do that? To change it like.
Now, sine of 3x is still a chain rule. My du, derivative of sine of something, will give me cosine of that same something, but times the derivative of that inside function. So if I solve for my dx, I'm going to get du over 3 cosine of 3x is my dx. So when we rewrite this integral now, we're going to get the integral of u squared times cosine of 3x. We're going to replace the dx with du over 3 times cosine of 3x. So cosine of 3x divided by cosine of 3x goes to 1, and we'll have 1/3, because the du over 3 is the same thing as multiplying by 1/3, u squared du. And that will become, I keep the 1/3 out front, u squared becomes u cubed, which means I get another 1/3 out front. I back substitute sine of 3x in for my u, and I need a plus c. And when I clean this up, we're going to get 1/9 sine cubed of 3x plus c. The integral of 3 times quantity 3x minus 1 to the 4th.
So u would equal 3x minus 1.
So u, a good choice would be 3x minus 1, because 3x minus 1 to the 4th is the most complicated thing. We want something a little bit less complicated. Then du equals 3 dx. When I look at this integrand, I see 3 dx is going to get replaced by my du. So the problem becomes the integral of, well, 3x minus 1 is replaced by u, and that's raised to the 4th power du. The antiderivative, that's a power rule problem. I'm going to get u to the 5th. So we'll get a 1/5 out front. Back substitute in for my u, and I get a plus c. So what should my choice for u be?
E to x plus x.
E to the x plus x. Because we don't want it to be the most simple thing in the problem. And so unfortunately we're picking the most complicated thing. That kind of goes against my rule. But if I pick that choice for u, I see that du is e to the x plus 1 times dx, and that's right there in the problem. So this is going to become the integral of u du. Do you see that? I replaced e to the x plus x with the u, and the du was right there in the problem. So the antiderivative of this would be 1/2 u squared, and we back substitute e to the x plus x in there.
Wait, did you go back first time?
Do you see it? Do you see an obvious choice for u and a du in the problem? So we're going to let u be x cubed minus 2. Then my du is 3x squared dx, which I see in the problem. So when I rewrite this, we're just going to get u to the 1/2 du. The antiderivative of that will become u to the 3/2. So we put a 2/3 out front and back substitute. Okay, here's an example where if I was taking the derivative of it, I would have to use the quotient rule. I can't split the fractions. There's no way to simplify this. So I must have to try U-substitution, but I do see a composite function here. So what would be a good choice for my u?
1 minus 2x squared.
1 minus 2x squared, then my du is negative 4x dx, which I see in the problem. So this becomes the integral of 1 over u squared du, which I'm going to rewrite that with a negative exponent so I see the power rule, right? So it's the integral of u to the negative 2 du. The antiderivative of u to the negative 2 would be u to the negative 1 with a negative 1 out front. And we back substitute in for our u. And the form of that answer is fine, but I could also rewrite it so that I didn't see the negative exponent. But I don't have to. That didn't simplify anything for me. It's just a little bit prettier to look at.
screw with us and demand that?
No. All right. All right, we already did something very comparable to this. It was actually more complicated. But when you see trig functions in your problem, derivative of sine is going to be cosine. Derivative of cosine is going to be negative sine. So I have to figure out which way to choose that. And so you want to pick the one that's raised to a power as your u, so that then your du will be the one that is raised to the first power. So I want to pick u equals cosine x here. Then du equals negative sine x dx. Well, I see the sine x dx, but not the negative there, so I'm going to need a negative in my problem, right? So this is going to become negative u squared du. So I saw the sine x dx, but I still needed to divide both sides of this thing by a -1 and put a negative in my problem for it to work out.
So would you rewrite?
So the antiderivative of this, I'll keep the negative out front. I'm going to get a u cubed, which puts a 1/3 out front. And my u is actually cosine x. And if you leave it that way, I don't need to see you move the notation. As long as you use those parentheses, I know this is the same thing
Being cosine cubed.
as cosine cube x. But if you don't have the parentheses, then it wouldn't mean the same thing, right? Because cosine x cubed is not the same thing as cosine x cubed. One of them is cubing the x, one of them is cubing the whole function.